All right, let's talk about something that's going to blow your mind. There's a new world record for internet speed, and it comes straight out of Japan. And believe me, this isn't just a small step up. It's the kind of thing that could totally reshape the internet as we know it.
So to really wrap your head around this, let's just put a number on it. This new record, it's 4 million times faster than the average broadband speed we have here in the US. No, I'm not kidding. That's not a typo. 4 million times. And this just lays it out perfectly. Look at this. Japan's new record is sitting at 1.02 petabits per second. Meanwhile, the average speed in the US, a respectable, but now kind of tiny-looking 285 megabits per second. We're talking about two completely different worlds here. It's not even the same sport, let alone the same ballpark.
So, who are the wizards behind this? Well, it's a team of researchers at Japan's National Institute of Information and Communications Technology. You'll see it called NICT. They're the ones who managed to hit that absolutely bonkers 1.02 petabits per second. And here's the kicker, they didn't just do it in a lab across a tiny distance. Nope, they proved it works over a simulated distance of more than 1,100 miles. That's insane.
Okay, so you've got to be asking, how in the world is this even possible? You know, the secret isn't just about having a more powerful laser or some fancy new computer chip. The real genius, the real magic, is actually in the design of the physical fiber optic cable itself.
So check this out. Inside this new fiber, they've packed 19 separate cores. Think of these as individual pathways for light to travel down, and they're all bundled together inside one single glass tube. But here's the part that is a total game changer. The whole cable is only about 0.005 of an inch thick. Why does that matter? Because that is exactly the same size as the fiber optic cables we're already using all over the world.
Let me give you a simple way to picture this. Imagine a single-lane road. Now, imagine turning that into a massive 19-lane superhighway. But, and this is the crazy part, you do it without needing any more space. You don't have to bulldoze anything. You're basically getting 19 times the capacity in the exact same physical footprint. It's an incredible feat of engineering.
All right, I know we're throwing around some pretty techie terms here, like petabit and multicore. It can sound a little complex, but trust me, it's not that bad. Let's just quickly break down what this jargon actually means, so it all makes sense.
So, first up, petabit. What is it? Super simple. It's 1,000,000 gigabits. You might have a 1 gigabit internet plan at home, right? And that feels pretty fast. Well, a petabit is 1 million times faster than that. It's just a gigantic amount of data.
Next, multi-core fiber. This is the core idea, pun intended, behind this whole breakthrough. It's just what it sounds like, an optical fiber that has multiple cores, or paths for the light, all inside one cable. In this case, 19 of them. It's what lets all that data travel at the same time in parallel. It is our 19-lane superhighway.
And finally, you've got this term MIMO. Now this is kind of the secret sauce that makes it all work. See, when you cram 19 signals into such a tiny space, they can kind of bleed into each other and get jumbled up. MIMO is a clever bit of digital processing on the other end that acts like a super smart traffic cop. It sorts everything out, untangles all the signals, and makes sure the data that comes out is perfect.
Okay, so now we know the terms. Let's dig into how the researchers actually set up their experiment. Because it wasn't just about proving the speed, it was about proving it could go the distance.
Their setup was actually really clever. They didn't have a 1,000-mile cable lying around. So what they did was take a 53.5-mile spool of this new 19-core fiber. Then they basically created a loop. They sent the data signal through that spool, and then a switch would send it right back through again 21 times. So by looping it, they simulated a total journey of over 1,100 miles. And at the finish line, that MIMO receiver was waiting to clean up the signal and prove the speed was still there.
Now this next number, 1.86, it might not sound as exciting as 4 million, right? But let me tell you, for the engineers who build these global networks, this is the number that makes their jaws drop. This is the capacity distance product, and it's a huge deal.
So what is that? Well, it's pretty simple. It just multiplies the speed by the distance, and that single number tells you everything. Look, getting a crazy fast speed over a cable that's like a few feet long, that's not that hard. The real test is proving you can maintain that speed over a long distance. A high-capacity distance product shows your system is the whole package. It's incredibly fast and it's reliable over the long haul. That's what you need to build a global internet.
So you've got this insane speed, you've got incredible distance, but honestly, the most important part of this entire story, the thing that elevates it from just another cool science experiment, is how practical it is.
And one of the researchers, Menno van den Hout, said it perfectly. He said, for fiber fabrication and deployment, it is highly beneficial to use fibers with a standard cladding diameter. What he's saying is, the real win here isn't just making a new fiber, it's making one that's a standard size. It's not some weird, thick, special cable. It's designed to play nice with all the stuff we've already built.
And that is where the practical genius lies. Because it's the standard size, you can literally just slide it into the existing ducts and trays and connectors that are already in the ground all over the world. You don't have to dig up cities to install it. This just crushes the cost and the difficulty of upgrading. It means we could do it piece by piece, upgrading the network step by step, instead of having to rip everything out and start over.
And that's really the main takeaway here. This isn't just about a flashy new record. This is a real, honest-to-goodness blueprint for how we can upgrade the entire backbone of the internet.
So it really leaves you with this one kind of mind-blowing question to think about. I mean, look at everything we've built with the internet we have today. Now imagine, what could we create? What problems could we solve? What could we discover if our internet connection was basically infinite? What does that world even look like? The possibilities are just staggering.